Well, good morning, everybody. Welcome to this introduction to PCI compliance and what that means to you as a user of an IBM Power System server running IBM I. My agenda today is pretty straightforward. I'm going to give you just a very quick introduction so you know a little bit more about me and why I'm in the capacity of being able to speak to you about PCI. We're going to give you an introduction and an overview of PCI itself, and then we're going to talk about, of course, the 12 requirements that comprise the PCI regulatory mandate. We're going to walk through how help systems can help in this particular capacity, and as you hear the content, feel free to ask any questions through the chat window, and we'll get to those at the end during the Q&A session. I am recording today's session. You will be provided a link to that recording at the end of the session. So my name is Robin Tatum. I'm the Director of Security Technologies here at Help Systems, and that means my role comprises of education of organizations with regards to security, compliance for mandates, as well, of course, for best practices, and I'm also one of the common subject matter experts in security. Now, my background is primarily technical. I grew up on the IBM I server, the AS400, the I series, so I've been on the platform now for more than 25 years, but I've also expanded that capability out onto the compliance side. So I am a certified information security manager with ISACA, and that is kind of the regulatory body that oversees most audit organizations. That is my direct phone up there if you are interested in making a note of that, and my email as well. I can post that at the end during the Q&A session. If you're feeling shy and you don't want to ask a question in public, I'll be happy to answer any questions that you may have after the session. So just briefly about Help Systems, known primarily, of course, for our automation tools such as Robot, but we've got a significant investment in security. It started originally with a couple of acquisitions, including PowerTech, which is one of the best-known security firms for IBM I solutions, but we've expanded and continued to grow that with acquisitions that include Skyview Partners and Lenovo Software. In addition to the software solutions, we also have an extremely comprehensive suite of professional services, very pertinent in the PCI space because it does include vulnerability assessments, security and risk assessments, and of course, mitigation services. There are two people primarily in charge of the security aspect at Help Systems, myself on the product side and then my colleague Carol Woodbury on the services side. Both Carol and I have been around the platform for a long time. In fact, you may recognize Carol's name from back in the IBM days when she was the Chief Security Architect for IBM. I bolded it here because I think it's most pertinent in this particular conversation, but Help Systems is also a member of the PCI Security Standards Council. So we try to stay as plugged in as we can to what's happening in both PCI DSS and the related mandates there. And so we do have some insight into those particular controls. We're also authorized by the National Association of State Board of Accountancy to issue continuing professional education credits for education in security. Means we do a lot of education for auditors as well as internal security staff. If you're not familiar with the State of IBM I Security Study, you may want to take a look at that. It's a free download from our website, but it is an annual study that we publish typically every spring that reveals a lot of what people are doing, or should I say not doing, in terms of IBM I security. So as an overview of PCI, what is it first of all? Well, the PCI standard was developed in order to encourage and really develop that cardholder security. We hear a lot in the news, unfortunately, still to this day and age, of credit card information being breached or that information being released. And obviously, that's a high-value target to anybody trying to obtain that information. Now, it was developed by a number of different security brands, or excuse me, card brands, that were attempting to ensure that the data that was being processed was treated with the appropriate care that it needs. Now, the foundation for PCI DSS requirements are 12 core requirements broken down into 6 control objectives. And we're going to look at those in more depth here in just a moment. Now, of course, the combination of these requirements along with desired testing procedures and audit procedures are really, again, the full picture of trying to ensure that that data is handled appropriately. Now, the intent for the PCI DSS standard is that it oversees both merchants and service providers who are servicing those merchants in order to process those credit card transactions. Now, each of the brands has its own set of validation and reporting requirements. So PCI DSS is kind of the baseline, but when you look at Visa and MasterCard, they're going to have some unique nuances with regards to their own particular requirements. But really what it comes down to is that any entity that is storing, processing, and or transmitting that data from the cards has to comply with the PCI DSS standard. Now, if you're a smaller company, perhaps a smaller merchant managing just a small number of card transactions annually, you may be able to complete a self-assessment questionnaire in order to determine and deem yourself PCI compliant. If you're a larger company, you're processing large volumes of credit card transactions, then you're typically going to have to pass an audit that's performed by what's called a qualified security assessor, a QSA. May also be an internal security assessor, but the intent here is that there is a third party that is overseeing that versus just simply answering some questions within a questionnaire. PCI typically has about a 3-year life cycle between releases. Now, this year was a little bit different. There was a mid-year release for version 3.2 that was published earlier in the spring. There's a 6-month cycle between that release and when the prior version expires. So we're actually coming up on the expiration of the prior 3.1 version. That then allows best practices to be accommodated for the next couple of years, and then in Feb 2018, those best practices become core requirements. So there's kind of a phase-in, phase-out process here. But traditionally, this 3-year life cycle sees some kind of release towards the end of the year, and then about an 18-month to 2-year adoption process before that standard then becomes core requirements, and then the cycle starts all over again. Now, the primary version 3 actually became a requirement in June of 2015. So as we saw, we didn't even make it a year before the 3.2 amendment was published, and that was partly in accommodation of trying to accelerate the expiration of use of technologies like SSL and early TLS, which are communication protocols that were deemed not totally secure, and they're trying to accelerate the change out of that to use more secure protocols. Now, one of the benefits that came with PCI 3 is that they tried to spend a little bit of time in the requirements trying to spell out a little bit more clarity with regards to what needs to be done in how you assess things. Now, there was reference to just mitigating vulnerabilities, and there was no real weighting of high risk versus low risk. So it was really up to the organization to determine what their prioritization was. In version 3 of PCI DSS, that was spelled out with a little more clarity. We're talking now high, medium, and low risk. Of course, we want to be fixing the high-risk items first, mitigating those things above and in front of low-risk items. Now, just kind of as a very brief history lesson here, PCI 2 originally required that there be external vulnerability assessments performed, meaning that somebody getting in from the outside world, from the internet, for example. And so those quarterly scans were performed by a lot of different vendors out there, and that was something that really focused on the risk of external penetration. Now, with PCI 3, we now have expanded that so it's not only external vulnerability assessments, but also internal assessments as well. Now, they're still considered quarterly, at least for now, and that's something that's not very easy for outside vendors to perform for you. A lot of times you're going to have a VPN connection into the network, and as a remote organization, that may not be particularly difficult or particularly easy, excuse me. Now, what will those internal assessments find? Well, that's anybody's guess, but I can tell you from an IBMI perspective, having done a lot of risk assessments myself in the IBMI space, there are definitely a lot of areas that we need to improve on, especially if you have an expectation of that IBMI server satisfying a tough regulation like PCI. The 3.2 requirement that was released earlier this year does include a two-factor authentication requirement for administrators. If you're not familiar with 2FA, it basically breaks down to the fact that passwords simply don't work as well as we would like to think. In addition to having a password, you also have to provide information that you know, such as a password, in addition to another factor, and that may be something you are, such as a fingerprint or a retina scan, or something you have. All right, and so very commonly a two-factor authentication is going to send perhaps a code to a device or a cell phone, a key fob. You may have seen that logging into your financial websites, your credit card companies, where they send a code to your cell phone and you have to enter that code in addition to the password. The intent there is if the password is somehow breached or leaked, that the user who has that information doesn't have the entire key to get into that account. Now, this is an area we can absolutely help in from a PCI perspective. We have a number of different solutions that are designed to help address that. Now, one of the benefits of IBMI is that there are a lot of security components built into the operating system. We talk about user profiles with special authorities and in other privileges, private, public authorities. We have the audit journal, which is a tamper-proof repository that does satisfy the PCI requirement for that component. We have system values. We have exit points and database triggers. We support all of the secure communications protocol, assuming that you're on relatively current OS releases. Now, these components are all there, but what we find a lot of times is they're simply not configured correctly, or they're not configured at all. There's not many tools in the operating system to help you with this, so we spend a lot of our time here at Help Systems in the security division working with organizations to ensure that their security infrastructure is optimal based on the components that they have access to. Of course, we also bring tools to the table to make that configuration easier or potentially to extend the function that is included within those OS components. Now, of course, as we build out a security model, we want to make sure that we are documenting how those components are being used, how they're configured. One of the biggest mistakes I see a lot of organizations making is that they go, heads down into trying to configure security, but they really don't have a baseline document that says, this is how my system should be set up. And then what they find over time is that while they may have achieved compliance at one time, the system drifts. The settings will vary. They will copy things and duplicate objects in settings, and they'll find that those controls don't stay optimally configured. So it's very important that you document and compare yourself against that document to ensure that your system maintains that compliance. All right, let's talk about the requirements of PCI. As I mentioned before, there are 12 requirements broken down into 6 different control objectives. Now, the PCI DSS requirements themselves have a lot of sub-requirements within them, so don't think that this is quite as simple as it looks here. But it basically breaks down into these 6 objectives: to build and maintain a secure network, to protect the data from the cards, to maintain a vulnerability management program, to implement strong access control measures, to regularly monitor and test the networks, and then maintain an information security policy. I think as a high level, some of that stuff is pretty self-explanatory, but surprisingly, especially in the IBMI world, we simply don't conform to that. Now, the requirements themselves can be delved into in depth at the PCI website. If you go out to www.pcisecuritystandards.org, you'll find a lot of documentation and blogs that are designed to explain and help you with satisfying each of these individual requirements, or at least interpreting what those requirements mean. And that's really the first step in all of this, is understanding what is it that they want me to do. And I think as you look down the primary requirement header, some of these are pretty obvious. For example, number 2 there, don't use vendor-supplied defaults for system passwords and other security parameters. Now, that sounds obvious, but I think you'd be stunned by looking at the IBMI security study that we publish of just how many organizations do leave passwords at a default setting, or that the system values still set the way IBM pre-configured them. In fact, I don't remember the last system that I looked at, and I'm talking I do 30 or 40 of these risk assessments in a week. I don't remember the last assessment that I did where a system had 0 default passwords on the box. So this is a very intrinsic problem that we need to address. All right, so these are the 12 requirements. We want to look at several of these throughout the session today. So I'm going to talk about several of them in focus. And I want to talk about how help systems can help address some of these particular challenges. Now, Help Systems has a core set of security solutions designed to address the challenges that most organizations face, whether it's PCI compliance on the table or any other type of regulatory mandate. And of course, not to be overlooked, is the desire to simply be secure. It's not just about regulatory compliance, it's about the idea that your data is in a good state. So we have these segments here that are designed to address all of the primary pain points that organizations have brought to us to say, how do we work on this? How do we improve the situation? The first segment, arguably the most important in my opinion, is simply the assessment phase. It's understanding how your system is currently configured so that you can get a feel of where the vulnerabilities are and how you can start going about fixing them. It's important that you do this assessment step first so that you have that line in the sand. Otherwise, really, you're just kind of shooting in the dark. You're trying to address things without knowing where they fit into the full picture or scheme of things. Now, Help Systems has 2 ways that we can satisfy this assessment objective. Number 1 is an IBM Security Scan. This is actually a piece of software that we have written specifically for this purpose, and it does a very rapid scan of the native IBM environment. When I say rapid, I've got listed up here, it takes under 5 minutes. Typically, it actually takes about 30 to 60 seconds. But don't let that fool you. It's still very comprehensive, and we'll spend about an hour with you on a WebEx going through those findings. Now, the best part of this for many people is that we don't charge for this. This is actually a service we provide to the IBM community. Now, granted, we do ask if you give us your permission to use those statistics as part of our State of IBM Security report. So when you look at that study, if you download that after the session, the statistics that we provide are actually obtained by people that are running this scan. If you prefer not to submit your statistics, you have that option. So still feel free to take advantage of this. It's a great executive summary. It's a good way to get a start and get some executive sponsorship. If you do feel that there may be some risk or vulnerabilities there in your current configuration, but you're not really sure how to go about documenting that, this is a really good first step in that direction. If you want to get into it a little bit deeper, then we also have a risk assessment offering. Now, this is a chargeable engagement, but it's not expensive, and it gets into over 100 different risk points that comprise the IBM configuration. Take advantage of this to understand all the way down into how your objects are configured as far as public and private authority and how your profiles are set up. It's going to give you a lot of depth, a lot of detail, and it's also going to map out some resolution to those common challenges. From a tool perspective, we have a whole suite of security tools that fall into each of those solution segments. I'm not going to go through all of these here, but I certainly will introduce them as we talk about each of the PCI requirements. If you are interested in learning more about the solutions, of course, check us out online or let us know in the chat box, and we'll be happy to share information with you. Now, the solutions and the services that go with them, of course, can be used to help comply with one or more of the PCI requirements. And because that's one of the most common regulatory mandates that we hear about and we have customers calling about, we actually spent some time mapping out all of the PCI requirements to specific security solutions. That's a white paper, a guide that we published. It's called PCI 3 Compliance for Power Systems Running IBM, and I provided the link here. If you simply go out to helpsystems.com, click on the Resources tab, and then select View All Resources, and then just search on keyword PCI, and you'll be able to obtain that document. If you're looking at this in a PDF document, you may just click on the link there. I just provided that for your convenience. So let's talk about the first control objective of the day here, internal access control. Now, there's several requirements here that kind of touch on this. Requirement 1, 3, and 7 talk about, of course, first installing and maintaining a firewall configuration to protect cardholder data. Now, I think most organizations have a perimeter firewall at this point. It's pretty mature technology. But what about those users who are inside the corporate firewall? They're inside the trusted perimeter. How are we going to control and manage what they're able to do and see on the servers when we've already given them the credentials to the network and probably also credentials to the IBM I server as well? Requirement 3 talks about protecting the stored cardholder data. Primarily, we're going to handle that through encryption of the data at rest. Understand that the IBM I system can handle encryption of data at a disk level and also at a database level. We're going to talk about primarily the database level because the disk level is limited in its usefulness. Quite honestly, in my opinion, the only thing that full disk encryption is going to manage is the idea that someone steals your disk units. And in the IBM I world, we don't deal with that risk as much because once you pull a disk unit out of the IBM I server, the single-level store capability of the OS means that that data is not readable. It's not like taking your drive out of your laptop or out of a Windows server where each drive has separate data. All of the data is scattered across all the disk units, and so the chance of you actually getting usable information off of one or even two drives is fairly minimal. But encryption ensures that. So if you do perceive there to be risk of hardware theft, then that certainly would be a beneficial layer. But what we're really interested in is encryption of the data at rest so that only the approved applications will see the plain text version. Requirement 7 then speaks to the ideal that cardholder data will only be accessed by personnel that have a need to know. It shouldn't be available to all users on the system simply because they have a user ID and password. We also bump into requirement 10 and 11, which are telling us to track and monitor access to network resources as well as cardholder data through those avenues. And, of course, requirement 11 telling us to regularly test these systems and processes. It's very, very important. We don't want to rely on the assumption that, well, we put the controls in a couple of years ago, and I'm sure they're still working. Help Systems has a great solution for the internal firewall control. It's a tool called Network Security. It plugs into an operating system facility called exit points that allow us to extend the function of the OS beyond how IBM originally designed it. But that integration is important because it means users are not circumventing those controls simply because they come up with a new way or a new tool that leverages some other technology. The intent with network security is to provide both visibility and control to interfaces like FTP, ODBC, and JDBC, and remote commands. A lot of people actually don't realize that you can run remote commands through these network services, and in some instances, those commands can even be run by users that do not have command line permission. Now, the ideal here is that we are providing a solution to two primary and one subsequent security risks in the IBM I world. One, there's not much visibility to the network activity inside the corporate firewall. So when a user downloads data through an ODBC connection or an FTP connection, there's really no log of that having taken place. You may, depending on how you're auditing the system, see that the user touched a particular file, but you'll have no idea of the SQL statement that was run that would extract that data or potentially update that data. We also have very little control of that network activity outside of object-level security. Now, don't get me wrong, object-level security is really impenetrable. It's a fantastic control if you have it configured, but if you don't, as most people do not, understand it's not something you're going to be able to mitigate overnight. Help Systems can certainly help with that type of project, and we do that for a lot of organizations, but what we're looking for is a supplemental layer that works in conjunction with that, and if that layer is lacking, provides some mitigation while you are developing a plan for solving it. So the goal here is to get a quick win. Let's oversee and control accesses coming from the PC and the network to ensure that those people are not circumventing the authorized applications. Now there's two interfaces available for this particular tool. We have both a web user interface as well as a traditional green screen. So depending on whether you're the new kid on the block or whether you're like me, you've been around the block more than once, you have your choice of how you administer the rules here. But the key is that it is a rules-based engine. It allows you to specify exceptions and rules with regards to who's allowed through these doors and whether you're going to track their activities when they come in. This is going to give you oversight of those actions so that you can then determine whether that's desirable or not. So instead of it being an all or nothing type scenario, we can choose to allow the approved business applications while rejecting those that are coming through questionable means. Reporting is provided so that we have, for example, the ability to know when a user has issued a particular SQL statement. In this case, we see here that this particular user, D user, ran an update statement against the database, and it provides the entire SQL statement. Gives us the service that was used as well as the date and time, and potentially also the IP address of the connecting server. Depending on the type of report you run, this particular report doesn't show that data because we're focused more on the transaction, but that is information that is available to you as well. Now, if you are one of the new kids on the block, just know that the web user interface here is what we call a scalable interface. So depending on whether you're looking on a PC, in a browser, or whether you're looking on a mobile device like an iPad or an Android or iPhone, the display will scale accordingly. Elements will add and remove depending on the amount of screen real estate available. But we have spent a lot of time modernizing the application so that you have that choice of user interface. Now, the other key component here is the encryption aspect that I talked about. IBM I has some great encryption features built in, but they're kind of difficult to use. They're typically API-based, meaning that you have to modify your application to call programs to encrypt and decrypt data. That means that we have a project that is very similar to a Y2K project where we have to search through the code looking for the points of access of the database and modify them. And if you don't own the application code or you don't have dozens of programmers just sitting around with nothing to do, that is not an ideal approach. Now, in version 7 of the operating system, we gained a facility called field procedures that allows us, in a similar manner to a trigger, to be able to invoke an encryption or decryption procedure autonomous to the actual application. So as far as you are concerned from a application shop, all of this is transparent. It all happens behind the scenes in the database. The user attempts to access the data. The field procedure can determine whether the user has permission to that field. If it's a social security number in the US or maybe a credit card number, maybe we want to mask the data and simply provide visibility to just the masked version. All of that can happen automatically in the field procedure, completely transparent to the background application. This was a significant enhancement in the OS function that simplified the encryption requirement and allows us to now easily satisfy requirement within PCI. There is key management built in, so you can handle key rotation. You can handle partial keys so that you don't have one person knowing the entire key. So all of the standard things we would expect to be able to address is all now inherently available within the IBM I environment. All right, let's talk about security reporting. That's a big aspect of PCI. Requirement 10 says we've got to be able to both track and monitor the access that is performed by users to those resources as well as cardholder data. And again, we see that they have to regularly test those things. Now, one of the challenges with IBM I data collection is the fact that the built-in operating system audit log is quite complex. Now, the logging function is a base operating system function. You simply run a command to turn it on. Straightforward, although it's surprising how many people are not using it. But once you turn it on, you'll discover very quickly that the data in that log is a little bit hard to decipher. What we want to do is make sure that we have clear visibility into that information so that it's going to provide more than just a data dump to us, that it's actually providing valuable information. Now, ideally, we're going to be looking at that stuff in real time. Many organizations have switched over to using some type of SIM solution or syslog server. In fact, PCI is very hot on that because their concern is if the log sits on the server where the event occurred, there's a possibility that a user could go tamper with that log. Now, fortunately for us in the IBMI world, we have a tamper-resistant log, meaning that users are unable to go change the entries. Doesn't mean they can't delete the entire log, but typically then you will see an entry in the next log that shows that they deleted it. So we have a really unique infrastructure in IBMI, and that's a foundation for us to build from. We can also do native reporting. There are some commands in the operating system that allow us to extract that data out, but if you've tried using it, you'll discover that it generates a lot of different work files that we then have to query or write RPG programs over, and it's just simply not conducive to a simple review of that audit data. Now, there's two things we can do here. One is we can escalate the events out both from the audit journal as well as critical OS messages and from some of the other help systems tools like the network security firewall that we just looked at into an industry standard syslog format. So if you're using some type of SIM, be it through ArcSight or Logarithm, Splunk, Trigeo, any of those tools are going to be able to interrogate a log that is sent to them in a syslog format. The benefit of this type of solution is that it is monitoring the IBMI environment in real time and sending those log entries as they happen. Now, as I mentioned, a lot of people are using these SIM solutions in order to monitor logs across many heterogeneous platforms, including other devices like routers and switches. Very beneficial to have all that log consolidation happening. It allows us to look for events that may really not generate a red flag if it just happened on one server, but if we see it cascade across multiple servers or hitting our routers and switches, all of a sudden now it becomes an interesting event. Unfortunately, the IBMI server has a tendency not to partake in this type of environment. So it sits just watching everybody else communicate, and we have to do all of our logging internally. Now, the benefit of this solution is that we're able now to move the IBMI so it is just one of the servers on the network communicating with that back-end SIM solution. One of the big benefits of PowerTech Interact, which is this solution, is the ability to selectively decide at the source which events are deemed critical. So we can make decisions about what time frame an event occurs in that would be deemed important, what user ID generates an event that would deem it important, or what event or what location that event originated from. So from that perspective, we don't have to flood the SIM with all kinds of events that are part of an approved application or high volume type activity that we know about and can justify. Lots of filters can be applied here so we can decide which events are sent and when, and then the SIM can do all of the correlation and fancy processing that gives you the dashboard view that SIMs are so valuable with. All right, native virus protection and detection. Why are we talking about that in terms of IBMI? I think a little bit of a controversial discussion here, and when I do an IFS security presentation, probably one of the segments that I get the most questions on. But native virus detection is a requirement of PCI. The directive for requirement 5 says we have to use and regularly update AV software or programs. But in the traditional sense in the IBMI world, we kind of skip over this. We dismiss it as, well, the IBMI can't get a virus. Unfortunately, that's not true. The operating system is susceptible to virus infection, primarily in the integrated file system arena. If you've heard of the IFS, you know what that is, then you'll know it's a file system that is just like most other file systems on the network. You can store Word documents there and Excel spreadsheets or MP3 audio files that can be just as infected in our world as they can in the Windows world. If you don't think you're using the IFS today, think again. The operating system uses the IFS. So if the IFS were to become destroyed, you most likely would not be able to connect to the system. Now granted, most of the risk is coming from users who are mapping drives into the integrated file system. If you have that happening, then your risk is definitely elevated. Now the good news is IBM recognized this fact and they enhanced the operating system clear back in version 5 with antivirus controls. Now because IBM didn't want to become an antivirus provider. They built the infrastructure, but they don't give you the virus engine. They turn to business partners like Help Systems in order to provide that function. Quite honestly, Help Systems didn't want to be in that business either, specifically because it is a very specialized industry. So we partnered up with Intel and the McAfee brand within them to actually be able to take their enterprise scan engine, their commercial-grade scan engine, and translate and port it to run natively on IBM I, fulfilling the missing link of the operating system function. It's a product we call StanGuard. It also runs not only on IBM I, but also AIX on Power, as well as Linux on Intel, and Domino on Power, meaning that we can use a single solution across all of those servers. Now, if you think that the virus can only be hosted in the IFS, maybe you've acknowledged and recognized that and read about it, understand that if the virus is activated and has access to the qsys.lib structure of the IFS, then it's also able to attack the native side of the house. Admittedly, the virus won't impact, or it won't infect those native objects, but that doesn't mean that it can't impact them. If a virus were to delete or rename or, of course, encrypt, which seems to be the new big thing, an object in the native side, then we really have a problem on our hands. So a very easy solution here is just simply to add the virus scan engine into the IBM I infrastructure provided by IBM and satisfy this requirement, but most importantly, provide you with that native protection against viral and malware infection. Without StanGuard antivirus, and this is a common problem that we see, we have the kind of cylinder of infection where a file may become infected on the server, be it through a PC that is no longer updating its signature files, or a virus that's taken the common approach to disable the antivirus on that platform. It becomes inherently infected on the host. It's going to then infect the PCs, which may or may not then catch that, may cleanse it. They're going to go back, they're going to reconnect to the host and start that cycle all over again. So it's important that we don't look at the IBM I server as the weak link in the chain that is infecting everything else, and of course, as I just said, also potentially being impacted by those viruses and malware. By adding StanGuard antivirus, we prevent a virus from spreading. So the operating system will check and look for infection in either a real-time mode or in a scheduled basis. And if it finds that infection using the same signature files that are being loaded in your enterprise scan engines on your Windows side, we're going to not only stop but potentially remove that infection from the object. Now, the good news here is because of some of the inherent strengths in IBM I, the antivirus engine is not able to be disconnected or disabled by the virus. It can't be circumvented because it is part of the license internal code as far as hooking in. So this is a much better way of trying to scan than doing it perhaps from a remote server that some folks try to do. We don't get the performance degradation of scanning remotely. We don't get the impact on a saved changed object that a remote scan would cause. So a lot of very positive reasons that scanning natively is really the only solution to scanning for viruses on the IBM I server. Easy requirement to satisfy. With configuration of this, we can determine which folders of the IFS we want to scan. We can determine if we want to use heuristic analysis, which looks for potential virus activity, even though the signature may not have identified it yet. We also have the ability to look in archive files and then, of course, to try and clean those files if an infection is found. If some file cannot be cleansed, it has to be quarantined, understand the operating system does that quarantining, so not even the security officer would then be able to access that file and become a spread infection. This is something we can schedule as well as run through the operating system's antivirus exit points, which are designed for real-time scanning. Here we see an example of a test virus that we supply. It's actually not something that will spread, so you don't have to worry about that. But in this case, we get a virus alert indicating that the virus was located, and that way we can identify it. But if you think that this is just something that is really just arbitrary and the only virus you'll ever find is the one that we test it with, think again. This is a screenshot that we grabbed from a customer that was heavily impacted. In fact, in the red box, you'll see they had 248,095 infected objects in their integrated file system. In fact, we've seen a significant increase in the number of systems that have been impacted by viruses on an IBM I server, and they don't have to be viruses written specifically for the platform. Don't think in those terms. It can be a virus that is written to simply cause havoc or to try and capture information on any type of platform, and it can impact us just as easily. All right, let's talk about auditing and reporting. Several requirements here talk about the necessity for users to be able to oversee the activities on the system as well as the configuration of the box itself. So requirement 2, I already pointed that one out at the beginning, not to use vendor-supplied defaults. Really all we have to do there is just look at user profiles that have default passwords. That one's a pretty simple one to satisfy. The tool that we have in this regard has a predefined report, and it also has a filter specifically to omit IBM system profiles if you prefer to do that. Requirement 8 says we have to make sure that a unique ID is issued to each person with computer access. So we have to have the ability to report over user profiles. We want to ensure that people are not sharing their accounts, and there are some OS controls that prevent concurrent sign-ons to the same profile. But we also have to provide a mechanism that allows us to gain the privileges of a perhaps service account without sharing that password with a number of different users. We also, of course, again, have to track and monitor all access to network resources and cardholder data using that firewall approach that we talked about already. This extends into requirement 11 and 12 that says we have to test things, and we also have to maintain a policy that is applicable to all personnel. Now, the operating system has audit functions built into it. I mentioned that. We have white papers on our website that tell you how to set it up, and it's really a very straightforward process. It's included in the operating system. But what we need to be able to do then is provide visibility into those log entries. Regardless of whether you have a SIM solution or not and you are escalating those events to a real-time notification engine, we probably also need to have reporting and forensics capability natively on the machine. We want to know who's reading objects, who is creating and deleting things, changing system values, and we need to be able to report on those proactively. One of the things that we do to satisfy the policy segment is to provide what we call a compliance guide. The compliance guide has a lot of regulatory information, including PCI, that helps you interpret these requirements into IBM I terminology and configuration settings. We also have an open source security policy, which is a document that we publish, that gives you a starting point to create a paper document for defining the access requirements to your IBM I server. Now, one of the modules we have has a tiered architecture, meaning that it is highly scalable regardless of whether you have one partition or hundreds of partitions scattered across multiple physical systems. It does not matter to us. It is all visible to the user interface. When a user submits a request, regardless of whether it's to one system or to many, the request will go out, gather the necessary data, and report back. Now, those reports can be based on one system, or they can be a single report indicating data across multiple systems, so a consolidated report. Now, if I have a dozen partitions, I don't have to deal with a dozen different reports. I simply get one report. Although, of course, the data does spell out which system that data came from, and you can filter to resegment it back to individual systems if you so wish. We have graphical scorecards to make it a little bit easier to kind of take that bird's eye view of the system. We have centralized storage of audit journal data, so if you do struggle with retention of information and the space that that data takes, we can get upwards of 90 to 95% compression on that audit journal data. All of this is, of course, designed to help comply with regulatory mandates like SOX and, of course, here today, PCI, but even if you're just dealing with internal security policies, that's an important step as well. In this product, we actually have a predefined PCI report category, actually two of them, one for the static configuration of the machine, like system values and user profiles, as well as then PCI log file reports. So the types of entries that the system can generate and log, we already have those reports predefined and canned. When the report comes back to the screen or is developed into your email, you have access to the content. Now, in our case here, we're just looking in a web browser. That's the default view. We also have tabs that allow us to filter that data, to sort it, and to export it out into Excel or PDF format for distribution or further analysis. Now, if you don't want to use the interactive display, simply tell the system what reports you want to see, the filters you want applied, and the sort order you want it in, and then tell it where to send that data. And it can be sent to a folder in the IFS, or it can be delivered directly to you via an email. Think about coming in the morning and having all your security and compliance reports sitting waiting for you in your inbox. The filtering function is especially powerful. All of the filters you see here in blue are actually predefined by us. I'm not suggesting you can't create your own. You certainly have a very powerful filter engine to do that, but we know what most people are looking for. We've been doing this a long time, so we've predefined many of the filters that I think you'll probably ever want access to. In this case, we grabbed the IBM Profiles filter, added it to the default password filter, and that way I can define, I only want to see any IBM profiles that have default passwords. The other thing we do is make audit journal reporting easy. Now, granted, the Interact agent is able to send those events to a SIM solution, and if that's the approach that you choose to use, no problem at all. Personally, I like to do some of this natively on the machine because a lot of times I find that the expertise on the platform is inherent in the machine more so than it is perhaps on a separate security team. So having the ability to pull out the system value changes that have occurred over the last 24 hours is of an important native capability, and this is all part of that static reporting as well. So this is a side benefit. If you choose not to use this and to send the events off in real time instead, not a problem. You still get the benefits of the static reporting config. I mentioned the scorecards. This is a nice bird's eye view. In this case, we've got some room for improvement. This is one of the servers on our network that we use for demoing and as a sandbox. But you can see some red X's here indicating that we've got system values that are not marrying up to the desired baseline policy that's built in. So if you do have a well-configured system, or if you know how you want the system configured, and PCI pretty much tells us that, we can compare many things to say, yes, you are compliant, or no, you're not. This works really nicely as kind of a pre-audit. So if your QSA is coming in, then you can have some preview of what types of things they're going to be looking at and how they're going to measure you against it. Now, I must point out, as an auditor, one of the things that I find quite ironic is that when an auditor comes into a shop, we all kind of scramble to run reports and correct our system configuration the day or the week before that auditor arrives. Truly, the auditor is there to ensure that you are overseeing the system on an ongoing basis. They are really not there to check your system as much as check you and check your procedures. So in a perfect world, we want to do this on an ongoing basis, a daily, a weekly basis. And when the auditor comes in, they're simply verifying that we're fulfilling that obligation. Of course, if we're going to do this on a daily, weekly basis, we've got to make it a lot easier than it is natively. And so these tools are designed to make that a much easier process in a much simpler way to address the requirements without relying on the auditor to point it out to us each year or each quarter. Privileged users. All right, this is a segment I love because this is one of the Achilles heels of the IBM platform. One of the sub-requirements of Requirement 6 talks about following change control processes for implementing any changes to system components. And then Requirement 7 that we've already talked about and introduced, but it's the requirement to restrict access to the cardholder data on a business need-to-know basis. Now, both of these things require that at some point a user is going to have privileges. We have to acknowledge that. There's no way around it. But what we want to do is make sure that when a user does need to access sensitive data, system configuration, those types of things, that it is done with oversight. We want to give a user privileges on an as-needed basis, right? So maybe temporarily elevate their privileges and then retract those privileges when they're no longer required. Traditionally, we find users who are either overly powerful or that have to maintain a second user ID, or we simply grant them access to a profile like QSEC offer in order to perform those tasks. A much better way is to allow the user to have one single profile of their own with minimal privileges, especially on a production machine, and then allow them to grant their privileges on the fly. Requirement 10 also allows us to link the access for system components to an individual user, meaning that we have to have accountability. We can't share a profile like QSEC offer across multiple users because then if something does happen, we have no way of proving it. Being able to elevate privileges still allows us to report on the activity based on who the originating user was. Now here we have a facility that allows a user to elevate privileges to a desired level. Now it's not a free-for-all. Of course, this has to be configured so that a user has permission to do that, but it means that a user can now perform tasks that perhaps they couldn't originally do. If you are familiar with Superman, then as I think probably most people are, think of this as Clark Kent going into the phone booth and coming out as Superman the other side. The user signs on as their traditional user level, they elevate their privileges, and when they come out the other side, they now have super privileges. But we're not doing that as a free-for-all. The user has reporting over them. They have alerts that will get triggered when the user performs the task, and we're going to now be able to satisfy that separation of duty by having somebody else have to approve the use of that proverbial phone booth. Here we have an example where a user has instigated a request for elevated privileges. They're giving us a reason for it. They're providing a call ticket, which is documentation that can be tied back to a call ticketing system if you have one, and then they're being given a choice of profiles that they have been configured to use. In this case, we have a couple of profiles that have been set up for Oshan, and in this case, one has been limited to a 30-minute use, the other one has been set to an unlimited time use. Now again, he's not seeing a full list of profiles here, only the ones that he's been predefined, but when he elevates his privilege to one of these profiles, either the timer starts and we send notifications out to the supervisors of this user. Reporting can be provided based on the commands that he entered. So after swapping here, you can see that Oshan was issuing a go to a menu. He ran a particular query. He did a start SQL. But you'll notice that the start SQL doesn't track what he did inside it, and that's an OS restriction. The operating system is only capable of logging commands, and that's what we're reporting on here. So we need more. We need to know what this user is doing in the SQL environment. Fortunately, we have the ability to capture the user's screens. So one of the features that I love about this tool and really made it a game changer was that it does have the ability to record the screen events of where the user went and what they did. This happens to be the SQL statements for this particular profile. It'll also show SST, DFU, PDM, QShell, anything that is acronym named that traditionally is hard, if not impossible, to view can now be recorded in a very easy way to review. Now I'm showing you a PDF that gets sent out of the product here, but we can actually view this in real time from another screen. So if Oshan had switched in and issued that start SQL, I can send a notification to the user that the start SQL was issued, and then perhaps as his supervisor I can say, I wonder what he's doing in SQL, and I can activate a screen share without him necessarily knowing it, and I can view the screens as they change on his system. So very comprehensive, much more comprehensive than the operating system provides, but in addition to that, much more easily interpreted and manageable. All right, one of the aspects of PCI is knowing when people are accessing the database. So requirement 3 says, first of all, of course, we've got to protect the cardholder data. Operating system controls will allow us to do that, but we also have to monitor those critical database files. The operating system doesn't do a great job of knowing what's happening within the data. It may know that the file's been touched, but that's about the extent of it. We need to have more information than that. We also have to establish a mechanism under Requirement 7 that allows multiple users access based on their need to know. All right? We have to have a deny all model set unless specifically allowed, but one of the challenges in IBM I is that the default security model is an allow all model, so it takes some configuration, comprehensive configuration, to ensure that that is corrected. So that takes some work in the OS, but it also requires some assistance to know what's happening in the database. Requirement 10 has a couple of sub-bullets here, implementing audit trails that are automated in order to be able to reconstruct events under the system component category, And then all individual user access to cardholder data has to also be monitored. So kind of imposing and quite overwhelming if we think about all of the approved applications that are accessing data. Looking for that proverbial needle in the haystack is tough. We're going to see everything, and maybe that's not desirable. What we're able to do here is actually segment and filter through those types of activities, looking for things that perhaps are questionable. So while the approved application allows a data change to happen, if a user DFUs the file, then all of a sudden we have an alert being issued. If the user makes changes to the database that perhaps fall outside the realm of what would be typical or normal activity for that field, then we have the ability to alert somebody and record that action to indicate there's something to be reviewed, while allowing the normal approved business applications to pass without necessarily clogging up the logs. We do this through a facility we call workflow analysis, which is determining that a database change has happened and filtering it based on what we expect to happen and what would be unexpected. If we determine that something is unexpected, we can generate an alert and report on that event. From a green screen perspective, here you see that a particular finance user called FinUser made a change to a file called TSTemp here via a program called QDZXDBI. Now that happens to be the IBM program for a DFU. So this data change was enacted through a DFU. It updated the database, and what we see is that the field address 1 was changed from River Ford Road to Park Road. All right, so we get the before and after visual here. Now this happened to be done through a trigger, but we also have the ability to read database journals. So if you're already journaling your database file, maybe for HA purposes, you have the ability to leverage that existing infrastructure. From a PC perspective, we also can generate emails. Here we see that Larry got a salary change that was pretty dramatic, and maybe that was based on somebody putting a decimal point in the wrong place, and so we're still able to collect that. We even have a manner of recording the fact that this was approved or not approved, and that can be reviewed as well. All right, with that being said, I'm going to open up for a few minutes here for Q&A. I do have a poll that I want to share with everybody as well. I'm going to open that up right now. If you want to answer that, it's just a quick 5-question poll, but it's mostly multiple choice, and so you can answer that. That should be visible now in your WebEx window, hopefully. Yep, obviously, as some of you are jumping into that. If you do have questions about the content or IBM Security in general, feel free to use the chat window to send those to me. If you don't see the chat window, you can use the little speech bubble icon up in the top segment of your WebEx window. That'll open the chat window up for you. All right, so I've got a question here. Somebody, Jake, asking, how do you sign up for the free security scan? Great question. 2 things. One is I did put a question into the poll indicating if you are interested in obtaining a free scan, but also if you just want more information, if you want to know what's entailed in the scan, go ahead and check that. We'll be happy to give you more background. It's a great service. There's no cost, no obligation in doing that, and we'll be happy to provide you some additional information, and then you can decide from there if you want to do it. Or you can go out to the website, go under the cybersecurity section of the help system site, and you can enroll there. Benefit of doing it in the poll is that you don't have to fill out the online form. All right. The security study, you've got a couple people asking about that. That is a download that you can pull from the website. It uses the security scan data from systems, so they're real systems that we're including the information from. And that's something, the 2016 study came out earlier this year. Typically we release that right before Common in the U.S., but that's been available now for 4 or 5 months, so you're welcome to download that. I'm busy working on gathering data for the 2017 study, so if you'd like to contribute to that, have us run a security scan. If you just want to see the contents, go ahead and download that. It's a free guide. You're welcome to take advantage of that. It's probably worth mentioning, too, lots of different articles and things on the line. If you've been out to our website in the past and you struggled a little bit to find things, know that within the last few weeks we have completely rebuilt and released a brand new website, hopefully a lot easier to find information. and we invite you to come out and visit us there. If you are not familiar with help systems, or you have kind of got the idea that we are automation more than anything else, then I certainly invite you to take a look at all of the capabilities that are now inherent within all of the help systems brands. If you see reference to PowerTech, that's our primary security brand, but it is still a help systems product line. And it includes the capabilities to do things like workload automation across multiple platforms, document handling, business intelligence and data warehousing, and even high availability. So take advantage of us in as many capacities as you like. Security is obviously a key component and a hot button today, and I think will remain a hot button for a long time. And that one's always out there. All right. Okay, so Kathy, can you repeat the name of the product I was demoing that did the reporting, etc.? So there are a few things there. Compliance Monitor is the name of the module that I had some screenshots from. We do have various modules that do different things, so certainly I would invite you, if you are interested or looking for some type of solution there for reporting, we'd be happy to show you those on a WebEx, and that way you can kind of marry that up to what your requirements might be. But the primary one I mentioned is called Compliance Monitor. All right. Okay, Gary, you asked how much is risk assessment and what does my not much cost mean? Okay, yeah, I was a little vague there when I said it doesn't cost much. I believe, and I'm maybe speaking out of line here, that it is $3,500, but I will absolutely be happy to get that firm for you. I know it does not exceed that, and it may actually be less than that. Let's see. Can regular Telnet and secure Telnet coexist in the same IBMI, or do I have to switch all of the emulation to SSL in one shot? Yes, absolutely, it can coexist. There is a setting on the Telnet server that indicates whether you are going to do secure-only connections or whether it's a mixed environment. Now, in order to go over to only the ideally TLS connection, then just bear in mind that you have to make sure all the clients have been switched over, otherwise all of a sudden you'll have people unable to connect. But yeah, they can coexist. All right, I'm going to go ahead and close the poll out. If you are in the midst of answering that, that gives you about 15 more seconds just to wrap it up real quick. What it looks like right now, 57% of people are within scope for PCI, probably why you're here today, right? But there's 30% of you that aren't sure. As far as whether you do a self-assessment or have a QSA, let's see, most people, looks like, do a self-assessment. So smaller organizations, or at least smaller quantity of card transactions, but about a third of you are handling that through a QSA auditor. The most additional or most prevalent additional regulatory mandate by far, Sarbanes-Oxley. 71% of you are dealing also with SOX. Followed by other, so I'm not sure what that would pertain to. Typically, HIPAA has really bubbled up, but only 14% of you dealing with that. All right, 57% of you have had a vulnerability assessment done on your IBMI. The one thing I always caution people about in that regard is that it's done by somebody who knows the platform, right? It's not just about scanning ports. There is a native side of that as well. But very interesting. I appreciate that feedback. All right, that's the end of the questions there. I appreciate you sticking with me, and like I said, we did record the session, so we'll make sure that you get a link to that at the end. We'll follow up with any other content and hope to see you on an upcoming webinar. Thanks again, everybody. Have a great day.